Thank you, Epic, for a very tremendous work you do for the whole photonics community and for bringing all of us today and other days to discuss important topics in photonics. It's my privilege to be here. My name is Lisouski. I'm taking care of business development at EssentOptics Europe. The topic of my presentation is broadband metrology solutions for high-end quality inspection of optical coatings. A few words about our company. We were founded in 2009. Our office is based in Vilnius in Lithuania, and you probably know Lithuania is a really photonic buzz right now on the market with a very big number of impressive companies active in optics, lasers, and photonics. We design and build high-performance broadband spectrophotometers, tabletop systems for quality inspection of optical coatings. And this is our own one and only business for the last 15 years. We have customer base in more than 30 countries, and the advantage of our company is that we have all the technologies in-house down to the monochromatic level. So we design and build hardware, software, firmware, we run mechanical design, PCB design, optical design, and so on. We cover a very broad range of systems and a very broad range of wavelengths. We go from UV, from almost 0.2 nanometers to 14 microns. And the whole product line from our company is actually divided in two main groups. The first group is those products which are designed to measure transmission and reflection on flats or prisms or cubes. This group of products is called photon-RT spectrophotometers. And we have two main systems. One system covering the range from UV to 5.2 micron, and the second system covers the range from 7.5 to 14 micron. And we also have a product line to measure transmission and reflection on lenses and lens assemblies, like objectives. Here we also have two main products. The one called Linsa 150, covering the range from UV to 1.7 micron, and the second system is focused on mid-wave infrared range. I wish to talk a little bit about each system. So this one, Photon-RT 0252 model, is the hottest selling system from our company. It has a very wide range, can measure transmission and reflection automatically at any angle of incidence with SMP polarization. The polarizers are built in inside. We have a capability to measure very small and very big samples. We are famous for very accurate measurements. The image shows here a reflection measurement of a very fine laser mirror at 45 degrees SP and average polarization. But the main issue about this image is that we don't have any changeovers. Actually, this is the arrow points, the area where we are changing gratings and detectors, and you obviously see no jumps, which are very typical for other systems on the market. We are very famous with this system for the world record broadband range. This record was set in 2019 and is still kept unbeatable. We do cover the range from UV to 5.2 micron in a single system, and the example shows here our capability to measure gold mirror broadband. We take very precise attention and care to routine, typical daily measurements of samples, which fortunately are not taken care by other companies. Take, for example, a case of transmission measurement of a sample at specific angle of incidence. Obviously, you know that there is a beam displacement, which depends on the three factors: sample thickness, angle of incidence, and index. So the beam is displaced, and none other system is capable to track this beam. What we do, if you look into this blue dot, this is a symbolic image of our detector. We actually move detector to catch the beam, and our detector is capable to track this beam all the way with the change of the angle of incidence. And this feature helps us to measure even polarizing cubes at different angles of incidence or semi-prisms. The image on the right hand side, you can see transmission measurement of SP and average polarization of the cube from 0 to 20 degrees with a 1 degree step. We see a growing demand for measuring of optics and coatings optimized for space applications. Example here shown the so-called multi-zone filter, which represents a very sophisticated design. Actually, a number of individual bands or filters attached one to another or coated all together. They are all different in dimensions. We are capable to measure them fully automatically. We actually map them out automatically in our system and measure them automatically. The example here shows an image where one of the band was just 700 microns in dimensions. The same stage, which is shown here, is used for characterization of linear variable filters. We teamed up with a company from States, Amigo Optical. They were very cooperative and supportive to provide us with a few very nice samples, and you can see the results of the tests of these samples. We moved to long wave infrared last year. This system is grating-based, is not FTIR. We cover the range from 7.5 to 14 microns and is designed for transmission and reflection measurements at different angles of incidence and polarization of coatings and samples with coatings optimized for long wave infrared range. We even can measure very thick samples at different angles and also compensate for beam offset while measuring transmission. Lens measurement technology is a pretty new one. We had a few cases from our customers saying that, okay, we want not just see the results on the witness piece, but on the real lens. And we want to see transmission and reflection of lenses, and we want to see reflection from different parts of the lens. And we have different lenses like convex, concave, spherical, aspheric. So the whole set of different challenges which the customer has posed to us. We have this technology and we have managed to develop a system capable to measure transmission and reflection from all that type of lenses. And the examples here show reflection measurements of convex and concave lenses at different points of the lens surface. All these procedures are also being done fully automatically. This system represents our challenge and results for measuring of lenses and complete lens assemblies for mid-wave infrared. The advantage of this system is that it's capable to measure fully assembled objectives or telescopes with an end-to-end dimension up to almost 700 millimeters. This part of my presentation is related to a very new product, which we will be showing this year. We see a trend of measuring ultra-narrow bandpass filters, so-called nano-band filters, or cutoff filters with extremely steep edges and coatings with high optical density. In fact, all that challenges, what we see, are not met in full currently with the metrology industry. We worked on that system for the last 2 years, and we have managed to design a system which is focusing on the coatings optimized for LiDARs, for fluorescence microscopy, laser safety, telecoms, space exploration, defense and security. This is a broadband tabletop system with a very wide range, with an extremely high spectral resolution down to 0.06 nanometers. We are capable to measure optical density up to OD8. Filter bandwidth can be as small as 0.1 nanometer, and slope steepness can be also as small as 0.02%. A few examples demonstrating our results, recent results. The image on the left shows our capability to resolve mercury emission lines, which is a yellow doublet. And the images on the right show real measurements of ultra-narrow bandpass filters for visible range and for near infrared range. The upper image, we have full width have maximum like 0.42 nanometers, and the image below has the filter has full width have maximum at 0.7 nanometers. The high OD measurement capability was also confirmed. This filter has extremely high OD, and we were able to measure up to OD8. That's a lucky coincidence that tomorrow we'll be showing this system officially at Optotech in Frankfurt. So if you are around or plan to do so, please stop by our booth. We will be very much happy to show you the instrument and make some tests as well. Finally, two questions which are EPIC famous for. What can we do for EPIC members and what can EPIC members do for us? First issue regarding our capabilities. We believe we foster advanced research for the companies which make coatings or make research on coatings or use coatings for advanced applications. And we help bringing cutting-edge coatings to market. Obviously, you cannot produce any better than you measure. And metrology is that last mile where the quality of your coating depends really on the accuracy of your metrology system. And what can EPIC members do for us? We are looking for more reference standards which can independently qualify our systems. And we are also looking for a cooperation with the coating companies or companies from photonics field, which can provide us with extremely challenging coatings so we can test our systems for ultimate performance. And as a result, bring better coatings to markets altogether. That's all from me for now. Thank you very much for your attention. I'm very open for questions. Thank you.